approaches regarding or based on the strategy to develop a vaccine were unsuccessful so far. And this is partly based on, or these approaches are based on virus-like particles, and these particles obviously don't reflect the real state of the virus. The only current approach which could be regarded as an alternative to this is based on the development of food additives which could be used as competitors or which contain competing oligosaccharides, for example, which can prevent the binding of the virus particle to the epithelium. So this is the idea behind it. The theory is that the virus binds via a lectin function to the surface epithelium, to make it more concrete, to blood group type carbohydrates, which are presented by glycoproteins or mucin type glycoproteins on the surface of the epithelium. And this is done in a multifunctional fashion, which means that a multifunctional lectin on the surface of the virus binds to a multifunctional carbohydrate surface. And this interaction is difficult to overcome with monovalent oligosaccharides. So milk contains a huge number of oligosaccharides, but in particular most of these oligosaccharides are monovalent with regard to the efficient carbohydrate structures which could compete with the lectin function. So our strategy was to find ways to identify within the complex fractions of milk oligosaccharides those which could compete in a more avid way, which means that polyvalent fucosyl residues in these carbohydrates play an important role. Yes, the only so far well-characterized oligosaccharide from human milk is 2-fucosyl lactose, which is currently produced in large amounts in a recombinant fashion in E. coli by a company in Germany. And this compound is really able to interact with a viral surface, and we and others have demonstrated that the IC50 values for this competition is in the range of about 20 millimolar, which is quite high. So the affinity of this interaction is not really high. But an adult human can uptake per day approximately 20 grams of this compound without developing diarrhea, so it may work. There are currently no alternative studies underway. The problem in norovirus investigations is that there is no animal model available at the moment. Not any of the alternative species, for example pig or mouse, are infected by the same norovirus strains. So we are currently working with oyster, because oyster are infected more or less by the same norovirus species. And they express also similar blood group structures, so they can be used as a model, but also there is a restriction because the oyster is not really infected. It's just accumulating the virus particle in the gastrointestinal tract.